This is Geometry 5.6. Today we'll be going over proving triangles congruent by ASA and AAS. Just a quick review on the other ways that you can prove that triangles are congruent that we already covered in Chapter 5. One of them is side, or SSS. Another is hypotenuse leg, or HL. The other is side angle side, or SAS. So the last two theorems that you could use for proving two triangles congruent, one of them is the angle-side angle congruence theorem, or just like with the other theorems, we have the abbreviation ASA. But just like with the other theorems, the order here is important. It's angle-side angle. The side is included between the two angles. So the angle-side angle congruence theorem states if two angles of one triangle are congruent to two angles of a second triangle. Let me just show you that. Here I have two angles of triangle ABC congruent to two angles of triangle DEF. And the included side between the two angles are congruent in the two triangles. Then the two triangles are congruent. Take a minute, maybe pause the video. Think about what sides need to be congruent in these two triangles for these two triangles to be congruent by angle-side angle. If you said side AC has to be congruent to side FD, you are correct. Then if I take a look at just one of the triangles, this is angle, side, angle. If you thought side AB, that would be side, angle, angle, or angle, angle, side. Even though, as you'll see, angle, angle, side is one of the theorems, those two triangles would not be congruent by what we're talking about right now, angle, side, angle. So, excuse me, these two triangles, ABC, are congruent. Triangle ABC is congruent to A corresponds with D, B corresponds with E, and then C corresponds with F. So you have to obviously be writing the correct congruent statement as well. So the last way that we can prove that two triangles are congruent is using the angle-angle-side congruence theorem. I could just change a couple of words from the angle-side angle congruence theorem to write the angle-angle-side congruence theorem. This would be the non-included side, and this would also be the non-included side, but it has to be the corresponding non-included side. I'll write that down, and we'll go over the angle-angle-side theorem in a second. So here's the angle-angle-side congruence theorem. Like I said, I just change included side in the first part of the statement to non-included side, and then in the other part of the statement, it had to be the corresponding non-included side. So if I have two triangles, let me call this triangle PQR and triangle STU. I have two angles of one triangle congruent to two angles of a second triangle. If I choose side PQ to be congruent to a side, that's the non-included side between these two angles. The included side would be PR. Same with side SU. That would be the included side for these two congruent angles. So if I choose, or if side PQ is congruent to a side in this triangle, it has to be side ST. That's the corresponding side. It could have been QR and TU congruent for these two triangles to be congruent by angle side. Either would work, but in this case, if I made it PQ, then that has to be congruent to ST or TS. I mean, technically, this could also be called the side angle theorem. That would be a correct way. You just never see it written like that, even though it could be written like that. But these two triangles are congruent specifically by angle side, or AAS. Triangle PQR is congruent to triangle STU.